Okay, folks, I'm going to try to cut this short on time. So what I've done is I've already done the work here for you. This will be posted on Canvas as Saul's version, as you know. But I want to let you know um, the yellow angle here, 3x minus 15 and 105, those are corresponding angles, so therefore they are equal to each other. When I get the value of x equals 40, I just plug it back in. That makes this angle 105. Well, these two angles right here are going to be supplementary. So therefore, I add them together, which of course I substitute 3x minus 15 for its value of 105, and then I get 50. Now, I want you to look over here at number 2. I kind of separate these a little bit for you. I will post a copy of this on Canvas, like I said as well. But 2x. Now, 2x and 54 don't have a direct relationship with one another. So I can maneuver the 2x over here because since these are alternate interior angles, they're going to be equal to each other, which makes these two angles supplementary. When I do that, I get an x value of 63, as you can see. All right, I'm trying to cut the video time down for you. So if you look at these two angles, 5y and 120, those two angles are same side interior angles, which makes them supplementary. And I'm going to circle them right there. So they add up to 180. And then you just solve and you get y as 12. Well, 2x and 108, these two angles right here, because this is a transversal, they are alternate interior angles, which makes them equal. And then we come over to number 4. Number 4, the obvious ones here are 120 and x. Those two angles are same side interior angles. So since that makes them supplementary, and I just add them together and set it equal to 180, and I get x is 60. Well, to determine the value of y, I've got to determine the value of this, which I plug in, and I get a value of 110 for that angle. And I'm going to go ahead and highlight this right here. So this is 110, and that is 110. So 3y plus 40 plus 110 equals 180 gives me a y value of 10. All right, that's a little bit of review from the previous sections. I want to kind of go over that, but I didn't want to take up too much time. So, all right, now 3.3. I want to prove that the lines are parallel. I have to save this periodically. All right, now before we said if the lines were parallel, then the respective angles were congruent. Well, we're going to flip that. Well, what's it called when you flip a conditional statement? It's called a converse. So the converse of corresponding angles. Now, that's abbreviated. It's a postulate. In some books, it's a postulate. In some books, it's a theorem. I really, at this point, I don't care which one it is. Just know it's the converse of corresponding angles. Here's what it says. Converse of corresponding. That's what you need to write down. It says that if any one of the corresponding angles are congruent, such as 1 and 3, or 2 and 4, or 6 and 8. I kind of did that a little out of order there, but you get the idea. Or even 5. If any one of those respective angles are congruent, and since they're corresponding angles, then that means that the lines are parallel. So we're saying if the angles are congruent, the corresponding angles are congruent, then the lines are parallel. So we're going backwards, basically. So before we said if the lines are parallel, then the angles are congruent. Well, this time we're saying if the angles are congruent, then the lines are parallel. We're just going backwards. So converse of, now the only time you ever use converse is proving lines parallel. So only use when proving lines parallel. All right. You only use the converse when you're trying to prove lines parallel. Let me say that again. You only use the converse when proving lines parallel. Make a note of that. I'm going to be emphasizing that a lot, so get used to it. All right. Now, 3.5. The converse of alternate interior angles. Once again, I'm not worried about if it's a theorem or not. It says if angle 3 is congruent to angle 6, or angle 4 is congruent to angle 5, then A is parallel to B. Once again, say if the angles are congruent, then the lines are parallel. And that is the converse of alternate interior angles. And remember, only prove lines parallel. We'll see if you're up to snuff when you get into class and know that you only use the converse when you're proving lines parallel. I'm getting into this, okay? I like this topic, so therefore I get into it. Okay, now, theorem 3.6. Same side interior angles. If angle 4 and angle 6 are supplementary, or if angle 3 and angle 5 have supplementary measures, then the lines are parallel. Converse of same side interior angles. If you could prove that the measure of two same side interior angles are supplementary, then you could prove that line A is parallel to line B. And you can also see that from the diagram, but you have, just because it looks like it, you have to be able to prove it. We'll talk about that more in class when we do some example stuff. All right, now, theorem 3.7. The converse of alternate exterior angles. Same format. Angle 1 and angle 8 are alternate exterior angles and they're congruent, or angle 2 and angle 7 are congruent. Then we can prove that the lines A and B are parallel. All right. So like I said before, we were given that the lines are parallel. Then we could prove that the angles were congruent or supplementary depending on the relationship. Now we're going backwards. We're saying if the angles are, in this case, congruent, then that means that the lines are supplementary. All right. Now, I'm going to throw one more thing your way, and then we're going to do some example problems. It says if two lines are parallel, and actually it's a different drawing, but I'll go ahead and draw it for you. It says if two lines are perpendicular to the same line, then they are parallel. So, and that's actually bad wording. So here's what we know. All right. So it says if A is perpendicular to T and B is perpendicular to T, then that means that A and B are parallel to one another. So that's parallel. As I like to say, oops, typo. It happens from time to time. So anyway, okay, now let's do some more. I'm trying to keep this as short as I can, but unfortunately I can't. So we'll do the best we can. All right, now this is what you need to know. All right, check your project, give the reason for each statement, and also prove which lines are parallel. So I want you to look, we're going to look at angles 2 and 8. I'm going to highlight them, 2 and 8. 8 is right there. Okay, so here's what you got to look at. For this one, the transversal is line L. All right, transversal is line L. 2 and 8 are alternate interior angles, so we know that. So if L is transversal, then that means that A has to be parallel to B. But why? And that is the converse of alternate interior angles. They are parallel. Line A is parallel to line B because L is the transversal for angles 2 and 8, and that is by the converse of alternate interior angles. They are alternate interior angles with one another, but to prove lines parallel, you have to have the converse. All right. 3 and 11. Now this time for 3 and 11, A is the transversal. So transversal is line A. So that means that these two are corresponding angles. And because A is the transversal, we're trying to prove that L is parallel to M, and that is by the converse of corresponding angles. All right. We're doing good so far. Now, look at 12. 12 and 14. I'm just going to circle those two just because we're kind of... All right. Now, in the case of 12 and 14, N is the transversal. So transversal is N. And then, with that, we know that they are alternate exterior angles. We also know that because N is the transversal, then that means that A has to be parallel to B, and that is by the converse of alternate exterior angles. Okay, 1 and 15. It's kind of tricky. If you look, they don't share a transversal. No shared transversal. So there's no straight. So no lines parallel. No lines parallel. All right. I hate orange. That's just my least favorite color. Okay, some of you like it, but I'm going to use it anyway. All right, 8 and 13. Not that it really matters here, but I just felt like saying it. I don't like orange. I never have liked orange, but I love oranges. I love orange juice, but not that it matters. But okay, now 8 and 13. I circled those. Those are same side interior angles, but transversal. Transversal is B. So those are same side interior angles, and we know that they have a sum of 180. So they are going to prove that L is parallel to M by the converse of same side interior angles. And then finally, my last one before we run out of time here, 8 and 6. They're vertical. Doesn't prove anything. Prove any lines parallel. Okay, I'm going to stop right there. We'll continue with part 2 here in just a